Hello everyone. This AV will give you a brief about Skylab Consulting. It is a partnership firm established in India in 2016, engaging in business management consulting for performance enhancement of apparel industries, aiming at efficiency improvement and cost reduction. We expertise in woven garment industries, knitwear industries, and made-ups. Coming to services, we have complete garment factory program and module-based program for garment industries. We offer complete garment factory program for existing factories and new factories, under which our scope of intervention would be from fabric, cutting, sewing, production planning, quality control, quality audit, industrial engineering, maintenance, finishing and packing to dispatch. For module-based, we have middle management training that includes industrial engineering training, supervisory training, and quality controllers training. Few of our unique training programs under middle management are training of trainers for operators, non-operators and checkers, cost per minute implementation, and establishment of performance monitoring system. We are currently working with 25 clients serving more than 40 brands located around 8 countries. Also, our mentionable collaborations are with International Trade Center and USA. Now, let's look into the results we have achieved. Skylab Consulting has successfully created 415 trainers, 18,776 workers, 168 supervisors, 220 industrial engineers, and 87 quality controllers. Our success percentage for improvement of existing factories over 25 clients is 92, and for new and module-based over 42 programs is 100. Apart from management consulting, Skylab, along with Honeywell Creations, have stepped foot into a brand new venture, Skylab, that is training digitization, where you can access all our training materials, learn at ease at your location through our online website, which is cost effective. Our training materials include cost per minute, quality management system, training of trainers for operators and non-operators, industrial engineering training, supervisory training, quality controllers training, and top senior management training for factory management. To know more details about us, our services, training materials, recent happenings, expert team, our clients, and client testimonials, check out our website at www.skylab.co.in. To collaborate and make a new change, do contact us and we will be happy to serve you. Thank you. Hello everyone. This AV will give you a brief about Skylab Consulting. It is a partnership firm established in India in 2016, engaging in business management consulting for performance enhancement of apparel industries, aiming at efficiency improvement and cost reduction. We expertise in woven garment industries, knitwear industries, and made-ups. Coming to services, we have complete garment factory program and module-based program for garment industries. We offer complete garment factory program for existing factories and new factories, under which our scope of intervention would be from fabric, cutting, sewing, production planning, quality control, quality audit, industrial engineering, maintenance, finishing and packing to dispatch. For module-based, we have middle management training that includes industrial engineering training, supervisory training, and quality controllers training. Few of our unique training programs under middle management are training of trainers for operators, non-operators and checkers, cost per minute implementation, and establishment of performance monitoring system. We are currently working with 25 clients serving more than 40 brands located around 8 countries. Also, our mentionable collaborations are with International Trade Center and USA. Now let's look into the results we have achieved. Skylab Consulting has successfully created 415 trainers, 18,776 workers, 168 supervisors, 220 industrial engineers, and 87 quality controllers. Our success percentage for improvement of existing factories over 25 clients is 92, and for new and module-based over 42 programs is 100. Apart from management consulting, Skylab, along with Honeywell Creations, have stepped foot into a brand new venture, Skylab, that is training digitization, where you can access all our training materials, learn at ease at your location through our online website, which is cost effective. Our training materials include cost per minute, quality management system, training of trainers for operators and non-operators, industrial engineering training, supervisory training, quality controllers training, and top senior management training for factory management. To know more details about us, our services, training materials, recent happenings, expert team, our clients, and client testimonials, check out our website at www.skylab.co.in. To collaborate and make a new change, do contact us and we will be happy to serve you. Thank you. Hello everyone. This AV will give you a brief about Skylab Consulting. It is a partnership firm established in India in 2016, engaging in business management consulting for performance enhancement of apparel industries, aiming at efficiency improvement and cost reduction. We expertise in woven garment industries, knitwear industries, and made-ups. Coming to services, we have complete garment factory program and module-based program for garment industries. We offer complete garment factory program for existing factories and new factories, under which our scope of intervention would be from fabric, cutting, sewing, production planning, quality control, quality audit, industrial engineering, maintenance, finishing and packing to dispatch. For module-based, we have middle management training that includes industrial engineering training, supervisory training, and quality controllers training. Few of our unique training programs under middle management are training of trainers for operators, non-operators and checkers, cost per minute implementation, and establishment of performance monitoring system. We are currently working with 25 clients serving more than 40 brands located around 8 countries. Also, our mentionable collaborations are with International Trade Center and USAID. Now let's look into the results we have achieved. Skylab Consulting has successfully created 415 trainers, 18,776 workers, 168 supervisors, 220 industrial engineers, and 87 quality controllers. Our success percentage for improvement of existing factories over 25 clients is 92, and for new and module-based over 42 programs is 100. Apart from management consulting, Skylab, along with Honeywell Creations, have stepped foot into a brand new venture, Skylab, that is training digitization, where you can access all our training materials, learn at ease at your location through our online website, which is cost effective. Our training materials include cost per minute, quality management system, training of trainers for operators and non-operators, industrial engineering training, supervisory training, quality controllers training, and top senior management training for factory management. To know more details about us, our services, training materials, recent happenings, expert team, our clients, and client testimonials, check out our website at www.skylab.co.in. To collaborate and make a new change, do contact us and we will be happy to serve you. Thank you. Hello everyone. This AV will give you a brief about Skylab Consulting. It is a partnership firm established in India in 2016, engaging in business management consulting for performance enhancement of apparel industries, aiming at efficiency improvement and cost reduction. We expertise in woven garment industries, knitwear industries, and made-ups. Coming to services, we have complete garment factory program and module-based program for garment industries. We offer complete garment factory program for existing factories and new factories, under which our scope of intervention would be from fabric, cutting, sewing, production planning, quality control, quality audit, industrial engineering, maintenance, finishing and packing to dispatch. For module-based, we have middle management training that includes industrial engineering training, supervisory training, and quality controllers training. Few of our unique training programs under middle management are training of trainers for operators, non-operators and checkers, cost per minute implementation, and establishment of performance monitoring system. We are currently working with 25 clients serving more than 40 brands located around 8 countries. Also, our mentionable collaborations are with international.
Hello everyone, welcome to the webinar session. It's an initiative taken by Skylab Consulting along with Honeywell Creation for training or for helping the apparel professionals in the garment industry. We have taken this initiative during the time where the entire world is facing COVID-19 pandemic issue. So entire world is facing a lot of problems and especially recession. So in this time, Skylab Consulting would like to do some value addition to the society and would like to keep the people around us highly motivated. So that is our intention towards this initiative. So we'll be having around 5 sessions in this particular week at, of course, free of cost. And then please, you can enroll and you can enjoy the session. We will get into the session now. I would like to start the session by giving a quote. A problem is a chance for you to do your best. So this has been, coined by Mr. Duke Ellington. So now everyone is facing a problem, but this is a good time. We have to come together and we have to find a way to come out from this particular recession. I would like to give you a few details of this session. There are more than 207. If I'm right, as of now, there are more than 220 registrations as of now for this particular session. And then participants are coming from around 7 countries. That includes factory management, apparel professionals, right from senior to middle management, and textile students also. As we haven't expected this much of registration, so if you can't able to log in Zoom to to get the video live stream. So you can visit our YouTube page, Skylab Consulting page. There the video is being live streamed. So you can have a look over there also. Great. And then before I'm starting a session, I would like to give you a few notes in terms of how to utilize this particular Zoom app to make it quite interactive. First of all, there would be a query box. Yeah. There would be a query box in your screen at the down. So please, if you have any query, you can write your query so that like after we will be covering 3 topics in this particular session. After every topic, I will go through the query box, and if I can pick up randomly 2 or 3 query, and then I will answer to your query. So that query box will be available at the bottom of your screen. And if you feel like the query is not answered, if you want to speak, to give, to raise your feedback or to clarify your query, please raise your hand icon, which is also available down. But please note, I can allow somebody to speak only if time permits. Please apologize. And finally, once we have done with the survey, when you are completing the session, when you are leaving it, then there will be a feedback link would be available. Kindly please post your query in the feedback form. So it will really help us to improve our performance in the next frequent sessions. Great. So this particular session, of course, is organized by 2 of our team members. One is myself, Mr. Nandakumar. I am a managing partner of this company. And one of our consultants did help in executing this presentation well, Mr. Mohan Raj. He is also a consultant in our team. Okay, let us get into the topics. We'll be covering around 3 topics in this session. Before I'm getting into the session, I would like to share a few words about the importance of industrial engineering. So many factories are realizing the need of industrial engineering. I can say recently, in maximum 5 years. Unfortunately, but if you take mechanical industry, the industrial engineering concept has been applied almost more than 30 to 35 years, mechanical, automobile, all those industries. But now only the government industry professionals are understanding the importance, because unless you have industrial engineering, you will be losing a lot of cost, to be frank. So you won't be utilizing the resource to the full extent. So in this connect, I would like to talk 3 topics which we feel would be of good interest to your factory. First one is the identification of skill gap. Second is line balancing of production line using Takt time concept. And third one, style changeover using SMED tool, single minute exchange of tools. So these 3 topics we would be discussing in detail. We will get into one by one. So first, I would like to give you some idea, and then how you can implement Takt time concept while you are doing the line balancing in your factory. Let's understand what is a Takt time. Takt is a German word, and then what it says is like all activity within a business is synchronized by a pulse, that is set by the customer demand. Anything happens inside the business that should happen according to the customer demand. That's what it says. Few more details about this. The customer can pull the production through the system at the right pace. So they can pull the production only at the right pace. And then one more important point is, as it is a full production, it removes the requirement of scheduling. What happens is, like when there are 50 to 100 people are working in a factory, so one of the key thinking with the production manager and the industrial engineering manager would be like, we have to ensure all the people are occupied or have been given complete work, because that's a push production. But in pull production, it removes the requirement of scheduling at all. As it is removing the requirement of scheduling, it's literally driving out the waste within the business. And finally, it helps in making work balancing. Everybody is working in a good pace. So it's nothing but it's a production activity linked to actual customer demand. And then it ensures like all production activity is synchronized from first process from the fabric receipt till the packing. Everything will happen in a flow. I would like to give few benefits when you are implementing this Takt time concept in your factory, no need of high capacity operator always. If somebody falls under Takt time, it's fair enough. You don't need to always push for high capacity operator. And its visibility, as it's a full system, WIP will be less, so you can easily identify the bottleneck. And you can look always where the non-valued activities are happening, and then you have time to rectify it. So it helps in better time management. Because of this, it is quite easy to plan line target. Eventually, it would result in on-time shipment. Okay, so let me take directly to you some calculations and some demonstrations of how the Takt time would be calculated. Let us look how to calculate the Takt time. As I told, Takt time relates to the customer demand to the time available. It's nothing but total production time available divided by customer demand. Let us find out Takt time for a specific order or style. First, let us know net time available in a factory. If a factory is working for 8.5 hours, that is 8 or 30 minutes, it is saying like 5-10 minutes. But whenever you are taking the net time into the Takt time, you have to take only the net time. That is, you have to exclude any lunch or tea breaks, any team briefing, any clean activities, or any maintenance activities. So I assume in that particular factory, out of 5-10 minutes, 15 minutes have been used for other activities, so that the net available time is 460. So now we got the net time on the factory. Now let us look into the example. For example, as per the shipment schedule in the line per day, on that particular line per day, then what it says is like 460 minutes, that is a net available time, divided by 1250 pieces, which results 0.368 minute. So for every 0.368 minute, one piece needs to be produced from that line. That is a concept. So I'm dividing the net available time by customer demand, so which is coming 0.368 minute, which is almost nothing but 21 seconds if I'm right. So for every 21 seconds, one piece should come out from the production line. So that is the Takt time. Okay, let us see another example. It would be of good interest to you. The factory is having order quantity of 150,000 pieces, and the production time available is 20 days. So let's understand what will be the Takt time. If I divided that, convert the 20 days into minutes, and then if I find the Takt time, it is 3.6 seconds. Do you think, is it possible for a line to get pieces for every 3.6 seconds? It's not practically possible. In that scenario, there is a way to approach. So first of all, you have to find the pitch time of the operation. That is SMV divided by number of operation. For example, if your SMV is 3, of that particular product is 3, and 10 operations are there, then the pitch time of that particular style is 0.3 minute, which is equal to 18 seconds. So you got the pitch time. Now, what you have to do is you have to divide the pitch time with the Takt time to know how many modules you have to run to ensure you are shipping the quantity perfectly on time. That is, number of modules needed will be 18 divided by 3.6, which is saying that like 5 modules have to be run, with each module have to run with the Takt time of 18 seconds. Hope it gives some clarity. Now, let us understand how to develop a Takt time chart in your factory. I will just go to an Excel sheet and then I would like to explain you in detail how it is being done. Okay, let me share the screen. Yes, so you will be getting an Excel sheet on your screen. Okay, fine. As I told, let us understand how to calculate the Takt time. I'm just giving another example. For example, this is a style number, which is 48 at the rate of pound. Okay, whatever the style number. The order quantity of 75,000 pieces with production lead time of 9. So it says every day you have to produce 8,333 pieces. And then the working time in the factory, net working time in the factory is 540 minutes. So if you want to calculate the Takt time of the order, I'm sorry, this is minute. So the takt time of the order will be, as I told you, are dividing per day estimated output by the working time. So it is 0.065 minutes, which is saying that like it's 3.9 seconds the piece has to come out. As I told, it's not possible. So we are getting SMV of the government, which is 8.72. In that particular government, there are 16 operations across the entire chain I am talking about. So if you find out, the pitch time would be 0.54. If you convert that into seconds, it's 32.7. So as I told, to find out the number of modules or lines needed, you have to divide the pitch time by takt time, which is saying 8.4 modules are needed. So the takt time of the line would be 32.7. But for safer side, to ensure I'm executing the order with 100%, so I'm just reducing 10% in the takt time. I'm allotting this takt time to the production floor. So I'm reducing 10% from the actual takt time, 29.7. Okay. So now let us get into how to develop the takt time. Okay. So one point I request you to have clear. Takt time is nothing but synchronizing the entire process towards the customer demand. So now we understand how much is the production needed. Based on that, we understood what would be the takt time of that particular floor. Then we converted into what would be the takt time of the production line. Now the another question is, if you want the pieces to be out for every 32.4 seconds, then all the operations in the line also should be synchronized in such a way that each operation can deliver a piece in 32.4 seconds. Hope it is clear. So now it is a time to see whether all operation can give output every 32.4 seconds. Okay. So now let us get back to the sheet. Now, yes. So now I have listed all the operations on that particular style which we were discussing, from front rise joint till ironing and packing. Okay. And standard time of the government also, you can get these details from your industrial engineering department. So whenever you are writing the operations, that should be right from feeding till packing also. If you have inline packing, you can plan takt time till the packing. So here it is inline packing. So I'm just writing down the SMB of all the operations. Then another point is expected performance. You can't find the takt time for against standard time or SMB. The reason is you can't expect all your operator to work at 100%. So the industrial engineering team knows what is the capacity or what is the skill level of the people inside. Based on that, against each operation, you can write down what would be the expected performance for that particular operation. For front rise joint, I have given 50%. So for inseam joint, it is quite easy. So I gave 100. So you have only waist top stitch, you have only operator who is performing at 60%, you are mentioning that. So you mention the expected performance for all operations. Then based on that, you will predict what would be the expected cycle time at the desired performance. It's nothing but you're converting the SMB into seconds, then you are calculating only for the expected performance. So it says the cycle time of that particular operation will be this. For front seam joint, it will take 30 seconds, whereas for inseam joint, it will take 65 seconds. So now you got it, how you can write the cycle time at the desired performance. Now, the another point which has to be noted is, whenever you are plotting a line, for example, that particular line has to produce around 8,000 pieces, something like that. So we would be discussing about the learning curve in the next session. So based on that product, based on the standard time, we explained what would be the efficiency curve. So here we gave the efficiency curve for running that order. It starts from 45 till 68 along with the output. So whenever you are making a takt time, please always develop the takt time for the maximum output. That is for 1053. So here I have given 1053 divided by 540, which is 29.4 seconds is the takt time. As I told, certain operations are more than 90. So now you have to identify how many operators are needed for every operation to meet the takt time. For example, in the first operation, it's only 30 seconds. The takt time is 29.4. So one person is quite enough. If you're seeing the third operation, that is a side seam joint, it's 90 seconds, but the takt time is 29.4. So you need minimum 3% to ensure that operation is delivering piece as per the takt time. So like that, you would be scheduling the number of operators needed for all the operation. Okay. Then another point which should be noted is FTT, first time through. Let me explain you what is FTT. Of course, you would be capturing the cycle time of the operation, but you have to consider the quality level of the work also. That is FTT. Normally, for any critical operation, you may end up with 3 to 4%. So FTT is nothing but first time through. Against 100 pieces, how many pieces potentially the operator can make mistake? If 100 pieces are produced, if 10 pieces are having defective pieces, if 10 pieces are defective pieces, then it says 90% is the FTT. Hope it is clear for you. So you can predict, for example, as industrial engineer, along with the production manager and quality manager especially, you have to predict what would be the FTT of that respective operation, from first operation till the last operation. For example, here I have predicted for trimming and checking only 70% is FTT, because there is a chance like pieces would go back and come back. And then for bottom hem, they estimated the FTT would be only 90%. Great. Hope it is clear. Now you have to plot it against this Amazumi chart. Amazumi is a Japanese term where we are including the FTT also. There is not much difference between Tack time chart or Amazumi. Okay, so here you can see the list of operations, the sequence of the operations, and each operation's Tack time has been plotted here. This red light says that the Tack time of that particular line, and then this blue line indicates the first time through of every operation. If you have a look, you can see like most of the operations are meeting out, that are coming under the Tack time, except few operations. Okay, the industrial engineer can work out a plan how to make that particular operation to come under the Tack time. Maybe they can share few percentage of that particular work to another operator to balance it. But I would like to show you the relation between FTT and Tack time now. See, already if you take this particular operation, the 10th operation, which is nothing but waist, elastic, turn and close, it's almost on the Tack time. Agreed, it is on the Tack time. But when I looked into the FTT first time through, it is only 90%. So what it says, you have to reduce the Tack time more. The reason is, if you make a mistake, then definitely you can't deliver the piece on Tack time, because there is a possibility the pieces would be defective. In those cases, you have to ensure, at least if it is a 29 seconds, you have to ensure you are making it under 25, so that you have time to rectify the defect also. So that's why we are rating FTT and Tack time together. So this particular chart would give you complete idea how you can initially do the Amazumi plan. Okay, so hope whatever has been informed to you as of now is very clear in terms of Tack time chart. Let me go back to the presentation, and then I'll see if I have to inform you anything else. Okay. So I think I am, yeah, okay. So another point is, as far as now we discussed only on how to develop a Tack time chart, to be frank, but we have not discussed how you can do balancing using this chart. Because of the time constraints, I don't have much time to do it. Maybe we can do this in a frequent session, but I'll just give you some rough idea how you can do it. Once you develop a Tack time chart, then every day morning you can take a cycle time and then plot it against the Tack time chart and see whether everything is falling under. Then the supervisors or industrial engineers can able to balance the line within 30 minutes. You can do the balancing as quick as possible if you do it. But we can discuss about how to do the line balancing using Tack time chart on a real-time basis in another session. Okay, so I just would like to give you some glimpse of some chart what has been followed. As I told, it's very easy. You don't need to have a very highly qualified people to use this particular system. They just need to know the basics mathematics. That is more enough. And then you can see the supervisors who have just completed 8th grade. They have done the plotting of the Tack time, and then they were doing it. What are all the operations? It's going high. What actions can be taken? This is for a factory we have done with one of our client in India. Okay, so yes, I almost done with the takt time chart, the first topic, and then I would like to receive a query if anybody is having. Okay, let me go directly to the Q&A session, and then I will see. Expected performance, how would you decide? Is it based on the performance? Okay, it's a quite good question. What the person is asking, like when you are writing, what would be the expected performance? For example, while calculating the takt time, how do you decide it? It should be done definitely not on experience. It should be done on the skill matrix. Because if the industrial engineering team is having a very strong skill matrix, very clear skill matrix with the skill level of the operator is completely mapped, you can refer that file to put it under the expected performance. Please don't do it on the experience, it would be wrong. Always go with the data. So the right data for this particular takt time expected performance would be the skill matrix. That would really help. So quite good question, thank you. And then I would like to see, is there any other question I can have? Okay. Please tell about FTT. Okay, it may not be clear. Let me tell you again. FTT is nothing but right first time true. The quality pass percentage. To be frank, it's only the quality pass percentage. Pass percentage is like out of 100 pieces, if you are making 10 pieces wrong or 90 pieces correct, then the FTT would be 90%. Okay, so hope it is clear. Otherwise, you can write a question to us and then we will try to answer. And there is another question from Mr. Vijay Kumar, whether this takt time will be efficient for small quantities like 3,000 pieces. Good point, but I can say this particular takt time concept will work if you have order quantity ranges between 10,000 to 20,000. What steps you can take for 3,000 pieces? I'm going to talk on that particular topic in the next session. So no problem. I'll be touching that particular point. But this particular takt time chart would work if you have an order quantity, or don't confuse with order quantity. I can say if you have styles, if it is a similar styles, it doesn't matter, because certain PO would be having only 100 or 200 pieces, but that style only would be coming regularly. So at that time, you can use this takt time. So for running low quantity styles, this is not an appropriate method. So that I will explain in the next session. Thank you. And then one more thing, cycle time want to take till end of the quantity. Yes, my suggestion is the supervisors or industrial engineers can take once every day. Every day morning, if they take the cycle time, that's quite enough. In the frequent sessions, we will also explain, because one of our colleague has a kind of discovered some new way of taking cycle time of the entire production flow or entire line within 5 minutes. So you can save enough time if you utilize that particular method that we can discuss in another session. Thank you, guys. I think it's quite time. I have to rush to the next topic. Questions are quite interesting. Thank you. Okay. This case study I would like to say, because one person also asked, have you implemented this particular concept? Yes, we have implemented in more than 10 factories in India itself. Let me tell you what would be the inference. The client achieved ramp up of production in sewing lines faster than 35% using takt time method. If they're using traditionally one method, if they are taking 10 days to reach the 60% efficiency, but by using this particular method, they were reaching in 6.5 days. And moreover, the ramp up of the production on a day. Normally what happens is the first hour output will be always low, then it will increase a bit, and then from third or fourth hour only it will reach the peak. It's a normal scenario. But as this takt time is enabling the supervisors to identify the bottleneck very quickly, the ramp up of the production on that particular day also is being achieved 50% higher productivity than other method. Great, thank you. Let us move to the next topic, which is style changeover using SMED tool. Let's understand what is the importance of line setting. Main line setting means when you're changing the style. So line setting is, if it is very efficient, you can able to control the cost to a maximum extent, because you will be saving the efficiency, or you will be having higher efficiency. then maximum utilization of the resource. And then if you have a very clear and structured line setting, it will help in hassle-free work, and you can able to forecast the plan also. Let us understand how to set a line efficiently. The first would be preparation of line setting through style analysis. See, before you're initiating the line setting, please ensure you have a strong preparation of that particular style. We will discuss that. And once you have done the preparation, then you have to do the efficient line setting. Let's see how you have to prepare, the team has to prepare themselves. First one, please ensure all resources are ready before initiation of line setting. The resources would be 4M only: man, machine, material, and method. Okay, all the resources for the line setting should be ready on time. Here we have given a simple checklist, again, one of our factory. Please, whatever the template or MIS I'm showing, it is for that factory. For every factory, it should be a bit different. Okay, please note that it is not a constant or standard format. So for that particular line, before line setting, they have to ensure all these preparations are done. Let me go one by one. Style operation breakdown, that is the takt time chart should be ready. And then the responsible person for that activity also has been included. Machine layout diagram should be planned, and then that should be kept, and then Amazumi chart. Operators allocation report is very crucial, because most of the time what happens is like the operator allocation will happen only during the line setting. So they during that time only the industrial engineers or production managers, they would experiment which operator would fit, but that's not a right way. So operators allocation against each operation should be ready. Size-set comments, pre-production meeting comments also from the merchandiser should be kept during the line setting. Machine availability, if it's of course guides and folders availability, cut parts availability, and cut parts quality report, header sample, tech pack file, and critical operation mockup, trims and accessories availability. That is very crucial. Normally what happens is the line would start, the thread won't be there or button won't be there. Please ensure all the trims and accessories availability are there, and trims and accessories quality report. So these are all the list of things which we indicated like this is needed before starting the line. And then another point is like, as I told, line setting is a very, very crucial process. What I mean a crucial process is like you need a very strong team to carry out the line setting. It is very, very important for the factories who are running less quantity orders, because there were a query also, because your efficiency loss happens only when you are moving from one style to another style. So any factory, especially who are working in women's wear and the kids fashion wear, so line setting is very important. So to ensure line setting happens, you need to have a very strong, dedicated team to carry out the line setting process. So here we indicated like what are all the team members you need. Of course, the line supervisor is needed for the entire line setting process. Line setting technicians, we recommend line setting technician. The role of the technician would be to train the people on the line if it is needed, and then he would be like a kind of multitasking person. He knows machinery issues, he knows how to handle the people, he knows how to solving the quality problem. He's a kind of multi-skilled person. Then line setting industrial engineers, that is also needed. Line setting quality controller and mechanic. I'm not saying that you need one person specifically for these activities, but you have all the people, but allot them. Please list out the name and get the signature so that they would be completely prepared for the line setting process. Great. So now let us move into line setting. Line setting is nothing but setup time reduction. What is setup time reduction? It is an interval between production of the one good part and production of the another good but dissimilar part. Okay, let me explain. It's nothing but the production of lost output of the previous style and the first output of the next style. The difference between that particular time is the setup time reduction. So when we look into the changeover process, there are three things would happen. Okay, one is low rundown period. Low rundown period is nothing but what happens is when the style is about to finish, the efficiency would drop. You can I'm doubtful whether this picture is clear, but till I explain. So you can see the efficiency is getting down. This is a low down period. And the next one is zero setup time, where no production is happening. Then Another is low run-up period, where the new style is coming and then it is taking the production. So all these three phases are very important. We will look into that. Okay. So when you want to do a setup production team setup, like what are all the things? As I told you, need to have a floor personnel. You need to have a set of team. Then training for the team is important. You just can't just have the team, because the training should be conducted for the team about this particular concept. What is the mission? What you have to do? The respective role also has to be defined. And another point, after the training, the video taping is very, very important. That is, the video recording of the entire process sequence is important. I'll explain you why. And finally, once you have done that, you have to find a way how to reduce the setup time. Great. So for reducing the setup time, as I told, we would be focusing on SMED system, that is single minute exchange of dice. It simply says that any changeover happens, any operation should not take more than 10 minutes. So that's what we are keeping it as a goal, any operation. So that's what it is saying. Okay, let us get into the process. Before SMED, as I told, I'm just going to explain you with a case study so that it would be quite easy for you to understand. So that entire line setting process of a shirt manufacturing factory, to be frank, it has been captured through video camera. So if you look into the time, totally 38 hours. It's a total time. Okay, it's not a working time, it's a total time, net working time. 38 hours, 29 minutes have been taken for the line setting. That includes operator waiting time itself is 12 hours, 13 minutes. Operator learning is 2 hours, 29 minutes. Machine setting took around 1 hour, 31. And then if you say a run-up period is nothing like the time that particular line taken to reach the maximum efficiency took 21 hours. So totally 38 hours, 29 minutes have been taken for the line setting. So that's why I ask you to do the video record so that you can classify the time wasted in each process. Then after that, you have to separate. Separate is nothing but external and internal activity. There are two terms which is in SMED concept. One is external and another is internal. External, what it says, like any activity that can happen when the machine is being stopped, those are external. For example, you can prepare the operator, you can get the machine layout done, you can get the OB done. So those are external activity. Internal is nothing but you have to stop the machine to ensure you are carrying out that changes. So that is internal. So please understand the internal and external. So the second step would be the participant should know what is internal and external, and they should know separate. For example, here, external activities are like arranging attachments, folders, feed dog, presser food, nets, bolts, threads, needles, getting all these things ready are external. And then, of course, if you have a strong planning, you can prepare the layout and you can identify the operator also. So through that, you can see, you can minimize some time during the changeover. Let me show here. So scenario before implementation, what we have done is we will change it. What internal can be converted into external. Before, the mission plan was happening internally only during the line setting process, but by implementing the SMED techniques, they made it external. They were getting all these things prepared. So line layout also, it was internal before, then it becomes external. And then few more things, operator allocation, as I told, it was internal, then they made it external. So like that, you can list out all the things. What are all the possibilities you can make it external, you can definitely do it. The next one is converting the internal activities into external. That is also crucial. If you have any idle machines in the floor, you can attach folder and guides in the machine and keep it ready before changeover starts. It happens because most of the factories are having idle machines with them. So you don't need to wait for the line to stop, then you have to do the arrangements. So it is like converting the internal activity to external. Whatever the machines available with you, you can make all those machinery settings changes, then you can keep the machine ready. And then, of course, you can use some error proofing techniques to speed up the process also. So the next process would be internal to external. So here also we have given like what are all the internals that has been converted into external. So the next point would be streamlining. Streamlining is very crucial. Adopt parallel actions. Before I'm getting into it, I would like to put a video to just 3 minutes or 2 minutes video that would explain you what I'm talking about streamlining.
But Holland comes in for a pit stop. Time to refuel and change tire. Newmore himself changes the tire. Only 4 crew members, including the driver, are allowed to work on the car. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch. The tires are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stopped.
Okay, so hope it gave clarity like what is the parallel actions. So you have a set of team in your factory. For example, 5 to 6 members would be there for line setting. So please ensure everybody is performing some activity so that you can reduce the overall line setting time. And just give few examples here. When the mechanic is doing the attachment or setting, simultaneously the operator can put the bobbin thread and needle thread. And then the maintenance team also, when the last machine bundle is over, they can start to set the machine for the next style. So try to streamline this particular activity. Okay, so now we did again the video recording. See, I'm just explaining only the concept, but if you get into the details, this itself need a 2 to 3 day session. Okay, to be frank. So before it was taking more than 30 hours to do the line setting for the same style changeover. After implementing the SMED concept, it took only 11 or 30 minutes. You see how much time has been saved. Okay, so I would like to give you in terms of graphical representation for the time being saved at each stage. Before SMED, let's assume it is 10 hours. After that, by taking all the external activities and preparing well, you can eliminate 3 hours. So your changeover time would be only 7. Then again, when you are trying to convert internal into external, both putting external and removed together, almost 5 hours can be saved. The changeover would be only 5 hours. And finally, if you adopting parallel actions or functions among the team members, you can again reduce 2 hours process. The changeover would complete in 3 hours time. Okay, so this is what I would like to say. Again, it is one case study for a factory. Before, that particular factory was taking 2 or 30 minutes to from the last output of previous style to first output of the new style. They were taking 2 or 30 minutes. That's the line setting time. And then we reduced that to 42 minutes. Average machine setting time has been reduced drastically from 34.6 minutes per worker to 12.6 minutes. The another point is, if you implement this particular concept more precisely, the time taken to achieve the break-even efficiency also has been improved drastically. Before it was 21 hours, it has been reduced to 7 hours. Great. So it gave some clarity. This particular templates, it won't be very clear to you, but still these are all few templates that you can design in your factory when you want to implement it. So this particular chart would say when you start the line setting of every operation, when it got finished, how much is the time. So you can use this chart to see where are the problem happened, and then you can take some solution. Okay, so I think I am done with the line setting question, and then I would like to take any questions from your side. Yes, there are few questions. Is there any format to measure the lost time reduction to track and track the action against that? Okay, I'm sorry, it's not a valid one. Sir, I am Sundar. Sometime during the line setting, there was some technical issue or there were some cutting issue. Due to that, the line setting was taking more than we expected. Because of that, cost was increased. Kindly give me some ideas. It's a good point, Mr. Sundar. As I told you, the preparation for the line setting is very, very crucial. So if you have mentioned cutting issue is happening. So that's what I told, that before you are completing, before you are taking any order to the line, please any particular quantity to the line, please ensure the quality process have been done, have been verified. The quality department verified it. We will be talking about the quality audit process in a quality session. There you will understand how to ensure the quality at needle point or at the particular department point, so that you won't have this much of issue. Please focus on the preparation checklist to ensure everything you have, then only you initiate the line. That is the only way out you can do the line setting in a proper way. Otherwise, it would be a complete collapse. I hope I answered your question, Mr. Sundar, and then I will look into any more query. Okay, good point. It's a practical question also. Mr. Muthu, if I'm Vaira Muthu, how can we follow the line setting preparation checklist in sudden planning? Oh, that's a quite different topic. First of all, you have to streamline all of the process. Then only you will have excellent planning. So that is a different topic altogether. Of course, if you don't have a proper planning, everything definitely it would collapse. But broadly, what we recommend to the factory is like, please ensure our 80% of the order are being stick to the plan. 20% is being in the escalation. So you can use the 20% for all the sudden planning and everything. If you have too much of planning difference, then definitely it's not possible to rectify. It's not possible to do effective line setting. That's my answer for you. Okay. Few people asked about what is the industry you tried. I'm sorry, I cannot able to reveal the industry name. If you want, you can go through the website and see our client list. Okay. Thank you, guys. And then I would like to take you to the next session, which is more important and relevant across any industry, which is identification of skill gap. Skill gap is nothing but, I would like to explain what it is, first of all. Skill gap is nothing but you have a skill requirement in the factory and you have skill demand. For example, you need this much of operator. For example, you need 15 flat lock operators. I'm just giving a rough numbers. 15 flat lock operators as a demand, but you have only 10 people. So the 5 is the skill gap. So hope you got what I'm talking about, the skill gap. So the major problem lies is how to identify it in a more scientific way. And then is there any tool to do that? So that we are going to discuss now. Okay. So first of all, why the skill gap should be identified? Very simple answer: to maximize the efficiency. So if you arrest it first, and then you can maximize the efficiency. So if you understand what are all the major reasons for skill gap, because it's not theory, the factory is not theory, it's practical. You'll have a lot of problems whenever you try something. So what are all the major reasons which results in skill gap? The first one is absenteeism. So mainly uninformed. The person who have not informed, you will end up with what to do. You don't have some idea. Suddenly the particular line will be stopping because of that one operator. There will be a skill gap. Absenteeism. Then second one is attrition, that is a labor turnover. And finally, new skills. The new skills, what I'm talking, you would be doing certain styles, but suddenly some new style would be coming from marketing end. So, and then whether the factory is ready to do it. At the time, you will have skill gap issue. I'll explain some ways how you can understand the skill gap. I'm not talking how to arrest it, how to understand gap across 3 reasons which we discussed. So first, for absenteeism, it is a culture. Please ensure everybody is getting informed leave. That is very, very important. Then what I'm trying to say is it's a culture. Don't say, ask like it's not possible. We also, the few of our clients also thought it's not possible, but it took minimum 6 months for them to ensure everybody is informing. At least now 96 to 97% of the people are informing in that particular factory. So please ensure informed leave so that you can plan. And then some other ideas which my friends were sharing is like To identify the skill gap quite early in the morning, you can have a punching machine with a network facility in the bus. For example, if the company is providing transportation to the employee, if the person is taking the bus at 7:30, so he can punch. So you will get to know what would be the estimated skill gap before 1 to 1.5 hours. For hostel also, you can have the punching machine. You can ask them to whoever is coming, please punch it. So what happens is the IE department will have some time within 1.5 hours to map who would be absent and what would be the skill gap. Few factories are doing very efficiently because they have a fixed manpower for that particular line. So through this punching mechanism, they are identifying the skill gap every line. That is also crucial. But the challenge would be mobile application availability. Educating the people how to do the skill gap analysis, that is a crucial point. Educating the people how to punch it in the early morning or how to use the mobile app is a big issue. But if you give proper training, yes, people would understand it. The second one is attrition. Of course, first of all, as I told, informed attrition with notice period. Informed attrition is very important. Of course, people will leave. No, they won't even pick up a call. It's a culture. The HR department has to play a role to do that. But here, if you notice, I mentioned the notice period. Something. What is notice period? The notice period should be the corresponding time to train and recruit and train a new person for that particular job. If, for example, if a site seam operator is saying that I would like to leave the job, okay, then the HR department should have a list. For example, for recruiting another person along with training that particular person, training duration. So if the recruitment is 7 days and the training would take around 20 days, so totally around 27 days, then the HR department should get a notice period to them saying that you can leave after 27 days so that you will be replaced by another person. You can plan some benefits or incentive to them also to motivate. So if you have planned attrition along with a notice period, then definitely you can understand the skill gap also and rectify it. The next point is suggestions for any skill requirement. You should have a MIS where you are mapping the entire skill matrix and what are all the skills needed. Normally what happens is any order would be confirmed, would come to production only after 45 to 60 days. It depends on the lead time, but ideally 30 to 60 days. So you have enough time. So when the order is confirmed from the merchandiser, you can receive the order's details and you can analyze the skill needed and then you can map it with the skill matrix to see how many operators or what are all the skills have to be trained. So in this particular way, you can do it. So these are all the ways you can understand the skill gap and how to arrest it. There are 4 ways to do it. First of all, as I told, permitted leave per section. Don't think factory as a whole. I have 400 people, around only 10% people were absent. So it's only 2.5%. Don't think in that way. Please educate the people to take permitted leave per line or per section. For example, if a line is having 20 people, the HR and production team can openly share, anybody can take leave, 1 person in this line. So they can prioritize it. So permitted per leave per section can help you in arresting it. Then of course, floaters deployment is another point. Most of the factories, new floaters, but unfortunately, are they developing the floaters to the right skill, to the right requirement is a bigger question. Okay, but again, it's a different topic. I would like to give how much floaters can be planned. For example, if your absenteeism ranges between, there would be always a range in absenteeism, between 4 to 12% or 4 to 10%, let's assume 4 to 10%. So then you can have that minimum absenteeism as a floaters. That is the 4% you can have them as a floaters. Okay, so you need to have a very clear plan for the floaters, and floater development strategy itself has to be very scientific way. Then only you can arrest a skill gap. And then the third point would be new skill development in training school by trainers. See, whenever the skill gap happens, it would be arrested by only 1 person, trainer, because that person is going to develop the skill to the person. So it can either happen in the training school or in the floor. For any minor skill learning, I suggest you can develop that particular skill in the production floor itself. In our training methodology, we always propose to have 2 types of trainers. One is training school trainer, another one is inline trainers. Inline trainers focuses on developing the skill only in the production floor. So these are all the ways you can arrest the skill gap. Okay, so as I told, we have a simple tool that will explain you how you can identify skill gap in your factory. So I'm not showing a full version, I'm just showing only part of the version. So this particular Excel sheet can be can give some hint to you how you can do it in your factory. Okay, I'm just pulling the sheet. Okay, sorry, not this one. Yes. Okay. I think hope people are looking into this particular sheet. Yes. Okay. So there are a lot of information. As again, I'm just trying to explain you what it is. There are multiple sheets you can see. I'll explain the purpose of each sheet one by one. The first one is the skill matrix. In skill matrix, you can see you have to mention the skill level of all the operators. That should be mapped perfectly. That says like operator name, employee number, along with what are all the possible operations you have in single needle machine. This is for a knit factory in South India. So what are all the potential operations you have? Basic, semi-critical, critical, and double needle also they have, and then overlock. So you are categorizing all the operations. Any similar operations can be put into one category, to be frank. So and then flat lock, flat seam also they have, and the special machine. So against each and every category, all the operators would be mapped. They would be mapped into 4 categories. Here they are mapping in 4. One is a superb, good, average, and a learning person. So you can use different simple. So this first sheet will tell you what is the skill availability in your factory. The next one is OB of the styles, the operation breakdown. So definitely you might have the operation breakdown of all the styles you are doing. So here you can list out all the style names and then operators needed on that particular style, along with how many operators are needed in each and every operation for that style. For example, if I take Mido trouser, we need 17.5 operators. One person is in label attach, one person is in hanger loop attach. I need 2 person in belt loop. So like that, I just categorized how many people are needed across all the categories. So this is a kind of library. So whatever the styles you are running in the factory, please ensure you are listing out all the styles. The another one is the running style. Running style is nothing but you have to list out all the line numbers in your factory. For example, if you're running 25 lines, list out all the lines. So once you list out the lines, once you pick the running style from the list, which you already have from the drop-down menu, so that would automatically take how many operators are needed for that particular line. So this would tell you how much is the demand. Hope you got it. How much is the demand? So I need this much of 21 operator from 13 operator from label attach. I need 7% from neck piping for that particular day. Please note it is for that particular day. Then you need to know the skill availability on that particular day also, because before you are seeing only the skill matrix. But on that particular day, how many people were present, what is the skill level you need to map. So you can list down the entire employee number. You can get this detail from HR. You just paste it, automatically the details would be taken from the skill matrix sheet, so that now you know the skill availability on that particular day. So through this particular sheet, you are understanding the skill requirement on the day, and this particular sheet, you will understand the skill availability on that particular day. Finally, through that, you can identify the skill gap. For example, as I'm saying that, like I'm just showing a portion of the skill gap here, availability for basic average, it's a basic operator, average, good, super, we classified it. So how many people are available on that particular day? So you're having the entire list against each operation, and the demand, the expectation or need on that particular day also be given here. Through that, you can identify the skill gap. For example, I have sufficient operators here. My bigger problem is, okay, let me take it to you. Okay, for example, to be frank, like I have, I have 5 people. The demand is only 3. Again, I have extra 2. So through that, you can identify if you have any skill gap in your factory that could be identified before welding time. So this is a way you can map the skill requirement in your factory. And then when you want to predict what would be the skill needed if you are getting some new styles, there is also during that time also there is a way out. So you can use again the same template, and then you can list out the OB of the new styles also into it, skill matrix. Through that, you will get to know what would be the skill gap. Okay, so I hope I answered your question. I mean, I explained it, so I'll just try to pick up few questions from the query, and then I will answer it. Yes, there is a question called, can we use floaters to tackle skill gap? Yes, of course, you have to have floaters. That's what I'm suggesting. Please ensure you have floaters to the minimum level of absenteeism you have. That person would be used at any point of time. So floaters are definitely needed. But the point is, floaters development strategy, what are all the skills the floaters should learn, that should be mapped precisely, and the development activity also should happen in a proper way. So that is very, very crucial. Yes, I'll try to have any other question. How can we follow line setting preparation checklist? And okay, that I answered. How important is machine strength in line setting? Okay, let me answer line setting later. Are new floaters can efficient to balance A grade absentee? Yes, that's a good point. Definitely floaters can be a multi-skilled operators, but definitely they are not a super performers. The reason is, if I learn one thing, I can perform to 100%. If I'm learning multiple things, then definitely my efficiency would be down. Maybe if I'm a floater, my average performance across all the operations would be only 60. So definitely the performance will go down. No doubt in that. You have to balance it. Please keep in mind, any floater cannot replace a A grade or high skilled operator who is doing a higher efficiency in that particular operation. That's not possible. The floaters will help you to enable the production is going. Maybe in due course of time, they can pick up the speed. But as I told, if you have a very clear plan on skill gap identification and arresting it, if you have a strong trainers, then definitely you can improve the performance if a new person also coming into it. Many factories, whenever we are doing a project, many factories used to ask like, why we need to have trainers, what supervisors are doing in the line. But we always recommend trainers are needed. Their only focus is to improve the performance. If some person is absent, if somebody else is sitting in the line, and then definitely the query has to be answered, the skill also has to be answered, and then they should be improved. So the responsibility of the trainer is only that. If you have very strong inline and training school trainer, then definitely that can be arrested. Okay. Hope I answered your question. And another point, one single particular operation knowing operator should be a floater or not? Definitely no. Don't encourage any single operation. They are not at all called as a floaters. Please don't do that. That is quite important. And then, do we need additional team to maintain this chart? Definitely no. Industrial engineer has to do it. Don't increase, because the problem is we are having more number of people because we have not defined the roles and responsibilities. Sometimes the management itself is asking quality to the production manager. They are asking production to quality person. So if you define the responsibilities, the industrial engineers are more than enough to carry out this particular activity. Final question I'll answer. Hope the floater should be selected who are highly skilled from skill matrix. Yes, highly skilled more than multi-skilled. Don't look into high skill. Don't get confused. The person who knows multiple operation can be the floater. Okay, I hope I answered your query. I would like to talk few points, and then I would like to conclude the session. The first point would be, okay. As far as I just do a sum up of what has been discussed, we discussed on identification of the skill gap, where we understand the skill requirement and skill availability, how to map it and how to identify the gap. And the second point is line balancing using the Tack time. We understood the benefits and case studies, because it's nothing but working towards the customer demand. This is the best way of doing it. And finally, we discussed on style changeover using SMED tool, single minute exchange of dice. Great. So hope it is a quite interesting session for you. If anyone would like to learn our material, because it's a webinar session, I'm not allowing you to speak or getting queries because we don't have time. If anybody would like to intervene, they would like to learn about each tool in a more professional way, of course, we have a e-learning subscription. You can contact the person. The details have been given here. And then one more request I have, please, after closing the session, please give your survey. so that we can see how we can able to give you better service in the next time. So thanks for your time. If you have any more query, you can visit our website, and then we have a Skylab. We have an online material also you can access, of course, based on the subscription. So it's nice talking to you. Hope we made some positive and value addition during the time when the world is being in recession. So best luck, stay safe. Thank you.